All right. So I am recording so that this can be put onto YouTube. This is just from your packet, or at least the packet I had from the spring semester. And then all I did was I deleted the intro information. But a lot of this stuff is just what you already have access to, assuming you got a similar packet. So what I'm going to do is I'm going to focus on the things that are considered like new. And then what I'll do is I'll tweak these questions and I'll create a separate answer for it. So this will change the key at the end. But that way when you see it and you're like, wait a second, why is that different? Actually, what I'll do is instead of changing the key, I'll just create a separate question. That way you don't have to worry about the context of well, what happened to that original question there. So, and of course that's gonna, there we go. Okay. So the first question that can be challenging is like one of these more like um multi-step kind of questions where you're doing some like microgram milligram conversions, accounting for the patient's weight, and it can kind of change some of the information. So what I'm going to do is I'm going to change up this information here just a little bit, just so we have uh, some variables that look a little bit different. So it gives you additional practice with how to do these things. So um, the patient's ordered dopamine infusion to begin at an infusion rate that seems a little bit weird, 25 micrograms per kilogram per minute. Now, it's not that weird because you've seen something similar with the heparin protocol where it was like 18 units per kilogram per hour. Okay. So it's just a little bit different, but they want to add a little extra complexity. Make sure you can know how to do your conversions going from micrograms per kilogram per minute to milliliters per hour, which is what we're going to do. It gives you a patient's weight. So I'm also going to change that. Let's just make this, let's just make it 50. All right. And then we want to do our calculation. So if you watched any of the previous 240 reviews that I've done, you've seen me work through this question. I always say, like, sometimes I'll start in a particular method and then I'll do something completely different. So it's probably what I'm going to do here. But my strategy always, when I have a weight-based calculation that I'm working with, is I want to account for the patient's weight. So the patient's weight is 50. Okay. And then I have to factor that weight into this 25 micrograms per kilogram per minute. So step one for me is I'm going to do 50 times 25 so I can have that taken care of. And then it's one less thing I'm worrying about as I solve some of these problems. So I'm going to take 50 times 25 and I'm going to get, so I'm just going to write that down. So I'm going to take my 50 kilograms times the 25 micrograms, kilograms per minute. And that's going to give me 1,250 micrograms per minute. Now, my goal is to get to milliliters per hour. Okay. So, and the reason I know that is because it says to calculate the infusion rate. Infusion rate is either going to be milliliters per hour or drops per minute. There's no drop factor mentioned in this. So I'm not going to assume drop factor. So that's how I know to do milliliters per hour. Okay. The other thing I have to keep in mind is I have micrograms per minute, and then my available is milligrams per milliliter. So I need to make sure those units are the same. So I have to do some converting. So the first converting I'm going to do is I'm going to convert micrograms per minute to micrograms per hour. And what I'm going to do is I'm going to convert minutes to hours. Now I'm going to do this in like a kind of like a choppy way. You can do one long dimensional analysis. You can just plug it into your calculator and do, times 60, divide by 1,000 or multiply by 1,000, whatever you have to do. I'm just going to show you stepwise how this looks. And then I'll also show you like the long form of it if that's something you want to see, but I don't think that's necessary. So in this first setup, all I'm doing is getting rid of minutes and converting it to micrograms per hour. And the reason I'm doing that is because ultimately that's what I want is milliliters per hour. So I just want to make sure I have that taken care of before I do anything else. So 1250 times 60 gives me 75,000. And that's micrograms per hour. Now, again, what I'm about to do next is only because I know that I'm comparing this to milligrams and I'm in micrograms. And I also, the other thing that I had going in my head was I wanted a big number because I'm getting ready to divide this by 1,000. Because there's 1,000 micrograms in a milligram. And what I'm going to do next is convert micrograms to milligrams. So I'm going to take that 75,000 micrograms and I'm just going to convert micrograms to milligrams. 1 milligram, 1,000 micrograms. And what I'm going to get is 75 milligrams per hour. So 75,000 divided by 1,000 is 75. So I have to do all that just to get to the available dopamine, the 500 milligrams per 125 ml. Okay. So you have to do all that kind of prep stuff. Now, if you just did 1250 times 60 divided by 1,000 and you were able to kind of navigate that, that's all I did. Okay. 1250 times 60 divided by 1,000. And I'm going to get to the 75 milligrams per hour. If you chop it up like I'm doing, it looks ugly, but it gets the job done. Once I have my 75 milligrams per hour, now I can calculate milliliters per hour. How do I do that? Well, I'm going to take my 75 milligrams per hour. I'm going to multiply. I'm going to convert milligrams to milliliters. And I can do that because of my IV or my suspension that I have available. Okay. And then I just put those values with the units that they go with. 500, 125. And then I just plug it into the calculator. So 500 times 75 divided by 125 gives me 300 milliliters per hour. So this is one of the quote unquote harder questions that you're going to get that's kind of new for you because you haven't had to do a question like this yet. Most of your questions have been pretty much just kind of working up to this point where they're anticipating that over the years now you have gained a new level of confidence and comfort with these medications that you can solve these more complex things where they're asking you to convert minutes to hours, where they're asking you to convert micrograms to milligrams and things like that. So good question. So someone asked, did I mix up the 500 milliliters and 125 milligrams on purpose? No, I made a mistake. So thank you for clearing that up. So I don't know why I did that. That's good catch. So let's delete this. Let's try that again since I'm clearly making a mistake here. Okay. All right. So let me start over again. Thank you for catching that. I was like, what did I do? All right. 75 milligrams per hour. So just in case you were sitting there going like, I think he did that wrong. I did. My setup was right, but my values were wrong. So this is 500. This is 125. Thank you for catching that. Which is good because that'll help us make a little bit more sense of what we got as an answer. So now the correct math on this is 75 times 125, which is 9,375 divided by 500. And I'm going to get 18.75. Thank you for making that correction. Yeah, so I got 18.75. And then you would round that to 18.8. So good job, those of you answering those, and thank you for making the corrections. So I give kudos to Yvonne and Usmita. I'm sorry if I'm saying your name wrong, Usmita. And then good job, Dawn, for 18.8. Okay, and then don't understand the first part. So all we're doing is multiplying by the patient's weight. Okay. And then you have to convert to make sure that you're in the same units. So micrograms, you have to convert to milligrams. Minutes, you have to convert to hours. So but if you do that differently, as long as you get to the same answer, the same portion, then you're doing it correctly. But that's why we're doing it. We're doing it because you can't compare milligrams to micrograms. They have to be in the same units. Okay, so step one. The kilograms was eliminated in the first step. So right here, so I take the patient's weight, 50 kilograms, multiplied by the 25 micrograms per kilogram per minute, and then I'm left with, I've eliminated kilograms at that instant. So this is just a weight-based calculation. Good questions, by the way. And then you saw where I made the mistake of switching the 500 and the 125, and you instinctively you made the correction. So if that's something that you do sometimes, and even when you've been doing this forever, like I have, you make those mistakes. And then I probably would have went along and went on to the next question and forgot to double check my work there. So this is always a reminder that even when you know this stuff really, really well, it's always a good idea to just double check your work, make sure you put the numbers and values in the right place. All right. So let me see what else I worked through previously, because some of these questions are, so, okay, this is one that gets commonly asked. So I'll leave this answer as it is. I can't remember if the problem was what the key said, but I'll create a separate question. Okay. Yes. So that's perfect. So if you changed the 500 milligrams to micrograms and you did it that way, that works too. Perfect. You're doing that right. So I'm not here to change anything like about that, as long as they're in the same units. So Lauren, if that's where you were asking, like, about the first part, I just chose to do it that way. You just need to make sure that the units are compatible, because you can't eliminate units that are different from one another. And then if you try and do like ordered over available and your units are not matching up properly, then it won't work at all. In fact, you'll get some very interesting numbers that won't be, unfortunately, the right answer. Okay. So for this one, I'm just going to change up a couple things. Let's just make it, let's say it's 60 milligrams per milliliter. Order 200. Let's just say the order is 150. Available is, let's leave it at 100. Okay, so this question gets asked a lot because and it even gets missed a lot because there's a lot of extra information in here. So this is where either you can use dimensional analysis with this, or you can use order over available. That works for this as well, or desired over have, whatever you call that. So the important things are, what is your order? And what is your available that you can calculate milliliters from? So when it tells you available dose furosemide 100, that doesn't really help me out. That just tells me like what the total quantity is in a given vial. What I need to know is the concentration. So I need a way to compare milligrams to milliliters when I'm calculating for milliliters for a particular injectable, and this is an IV solution. So once you know that, you can take your available, or your order, I'm sorry, divided by your available, and then multiply by your quantity. Yeah, and then you should get, I think that's what I got to, Lauren, is 2.5 milliliters, and that's your answer. Yeah. Perfect. So I think the thing that like previous students that got stumped on this type of question is this right here, the furosemide. You just ignore it. It's extra information. It's just telling you on the label that the total is 100 milligrams and that you have but it's actually 60 milligrams per milliliter.
Dr. Red, can I see 11, question number 11? The practice I did is I got the wrong answer when I compared to the answer sheet.
What did you get as your answer?
I got a point 0.22, but and the answer sheet is a 22 only. But yeah, I don't
Okay.
know.
So walk me through how did tell me what you did. So
I
like if you have
did
it
yeah, I convert 400 milligram to the microgram, like multiply by 1,000, like a 500 microgram. I set up my formula like kg, I cancel kg, and I convert 400 milligram to the microgram. I said what I did is 500 microgram. I have a different way to set up, yeah. And yeah, 5 micrograms times 70 times, I put 250 divided by 400,000 when I convert like 400 milligram to the microgram. No, I did no.
it's okay. I'm trying to follow along with
No,
what you did.
no,
That's
I
okay.
said that 5 microgram times 70 times 250 ml, not
Okay.
4,000
Thank you. Okay. So 5 micrograms times
times 70
70
times 250
Okay.
divided by 400,000. Like I converting 400 milligram to microgram. That means like, yeah.
Okay. Okay. And then anything else?
That's it. It also says like, infusion rate, like minute or hour, whatever. I just got the answer in minute. I didn't convert in the hour. It doesn't say an hour.
Right. So you have to know that anytime you're calculating an infusion rate, it's milliliters per hour.
Oh,
So the only thing you're missing here is multiplying by 60.
60.
Mhm.
Okay. I missed that part because I was late to come in.
Well, no, I didn't even I did a different scenario down here or down in the lower part here. But yeah, you're fine. Yeah, just you want to make sure you multiply by 60 because you want to convert minutes to hours. And then, okay, I see what you're saying. Yeah, and then you need to know that you're solving for milliliters per hour. Now, usually I think on your actual test, they'll tell you that. So I don't even know why they didn't on here, but whenever they ask you for flow rate, you're
Mm-hmm.
looking for milliliters per hour. And whenever they ask you for drop rate, they're looking for drops per minute. So that's how you kind of distinguish between those. And then if you get like an answer like, 0.22, then like, okay, I did something's not right here. So, okay.
Thank you.
Yeah, but otherwise you set that up perfectly. So it looks good.
Okay.
Get rid of this because I was not following along there. Okay. So again, what you can do, like others have done, you can convert your milligrams to micrograms right off the bat, and that's perfectly fine to do. Now you know how to do the other way too if you want to. Okay, I did that. I just want to see because I've worked through some of these other questions over the years, and I always like to just to double check to see if there's anything else that I specifically worked through that I thought would be good to do. Okay, that's just the key. Now I do think the key for 11 should be right. Can't remember if it was one of these was wrong, but it might be just a different packet. So what I showed you there, the those two questions are really the only ones that are not that one, but this one right here is really the one that's different as far as the questions that you've already seen throughout the previous 3 semesters. But I'll ask you like if there's any particular type of question you want to work through or see or just kind of get a better understanding. Okay, thank you, Megan. Just right out there. Just throw it out there. All right. So 31. Okay. So weight-based calculation, doing a heparin protocol where we take the patient's weight in pounds, convert it to kilograms. So in this scenario, they took the patient's weight 198 pounds, and then I just wanted to make sure that it is 90. So 198 divided by 2.2 is 90 kilograms. And then we're going to do what it tells us to do. It says to answer the 2 questions below the protocol. Remember, all these numbered segments are the protocol. And what's crossed out are things you do not need to solve as far as the protocol is concerned. You just need to calculate a bolus and then calculate the infusion rate. So let's go through that. So we know that the patient's weight's 90 kilograms. We know that we're supposed to start a bolus at 80 units per kilogram and then start an infusion at 18 units per kilogram. And we have the following available to us. We have 25,000 units and 250 milliliters half normal saline, and we have a bolus dose of 1,000 units per milliliter. So we need that information in order to solve for the questions listed below. So let's calculate the initial bolus. And what I'll do is I'm going to, there we go, add some spacing. All right. So 90 kilograms is the patient's weight. And I'm multiplying by the 80 units per kilogram. So very similar to what we did in the previous question, except that it's not kilograms or micrograms per kilogram per minute. It's just units per kilogram. So 80 times 90 gives me 7,200 units. Now I don't want units, I want milliliters. So I need to convert units to milliliters, and I do so by using the bolus dosage strength. Now, you've probably noticed that the bolus dosage strength seems to be the same, and that's because this is the standard protocol. If you do a Google search for heparin protocol, you're going to see bolus is 1,000 units per milliliter, 25,000 units and 250 milliliters half normal saline. It seems to be the constant. Okay. You can do order over available for this or desired over have if you want to. I'm just going to do it like this. I'm going to say 1,000 units per milliliter. And I'm going to get an answer of 7.2 milliliters. The only thing that really changes with this initial bolus question is the patient's weight. Whatever the patient's weight is in kilograms times 80 divided by 1,000. And that will give you the initial bolus as long as you're following the standard heparin protocol. So as a challenge, what I would tell you to do is take your weight, your significant other's weight, your kid's weight, your parents' weights, a friend's weight, convert it from pounds to kilograms, and then calculate a bolus, calculate an infusion rate. And if you want some to make sure you did it right, just email me the weight you used, and then I'll tell you if you got the right answer or not. For the infusion question, patient's weight is 90. And then it tells me to infuse at 18 units per kilogram per hour. So I'm trying to get rid of kilograms in my first step each time, right? Because that's kind of and if you remember where this came into play, because in 230 you took pediatrics, and you know that weight-based calculations are very, very important, especially for the little guys and gals out there, because you don't want to give them an adult dose. You want to titrate it down based off of their weight. This is sort of the same thing with heparin. You might have someone who's bigger or someone who's smaller, and you're trying to figure out a way without necessarily knowing all of their metabolic, activity, but you can use their weight as a guide. And then after you kind of check after they've been on the protocol for a little bit, then you can titrate it and change it. You can either increase the dose or decrease the dose depending on the response. And we'll talk about that in a moment. So 90 times 18. Gives me 1,620. And that's units per hour. And then we're going to convert units per hour to milliliters per hour. Sorry. Oops. That's not what I meant to do. Milliliters and then units. My available was 25,000 units in 250 milliliters, half normal saline. And then I get 16.2 milliliters per hour. So anytime now, don't get hung up on, because I know it says IV drip. And if you think about it, 16 milliliters per hour is very, very slow titration. It's coming out very, very slow. It is dripping. And then you might be thinking like, well, what about like drop rate? You could calculate a drop rate if you knew the drop factor for the tubing used for this. And then you can say like, oh, okay, it's going to be, whatever, 50 drops per minute, which then could eventually lead up to and understand that that's going to get us to the 16.2 milliliters per hour. That's just not what they're asking for in this particular type of question. So that's why we don't do that. So again, if you want to challenge yourself, just change the patient's weight. Use your weight, use someone else's weight, make up a weight, and then run through the scenario. And if you need feedback on your answers, just let me know and I'll make sure to give it to you. Just email me the patient's weight. Now, another thing that they did is they said, here's another scenario, but it's the same weight. So I don't know what the alternative is here. So I don't know why it says alternative, because it didn't. Oh, the alternative here scenario, maybe I made this up, is we get rid of the whole protocol and everything is right here. And this probably makes a lot more sense when we look at it this way: patient's weight, bolus, like what to do, and then what's your available, and then you just calculate and you'll come up with the same thing. So I didn't change anything in this alternative scenario. I just simplified the way the question's being asked, so there's not all that extra information in there. All right, any other questions or any other numbers to work through? All right, 24. Okay, got it, Kate. All right. All right, so okay, so this is one of those questions where there might be a little bit of extra information that you don't need to know. So I always like to give you that as like a clue. But the patients receive Solumedrol 200 milligrams IV. It's received in the pharmacy in a 120 milliliter bag of dextrose 5% water to infuse over 30 minutes. Drop factor is 10. No other IVs are running. What is the correct flow rate in drops per minute? So the first thing you need to know is that 200 milligrams IV, that's just telling you what the vehicle is, but they're not asking you what type of vehicle, they're asking you the speed, and the speed is the rate. So we can ignore 200 milligrams IV. Don't really need to know. That's important, obviously, for clinical standpoint, making sure that the patient's receiving the correct medication. But what I care about when I'm calculating drop rate is I care about the volume, the time, and the drop factor. And so when I do this, I just take the the 120 times 10 divided by 30, and I'm going to get 40 drops per minute. So I will say, now that you're into 40, they're going to give you that extra challenge of making sure you can discern which information you need to solve a particular question and which one and what you can ignore. All right. Any other questions? Take your time, look through. $27. Got it. Okay. So 27, 26. This is a yeah, so why don't I just do 25, 26, 27, since those are all kind of coming in together, because they're all basically the same question. The question is convert units per hour to milliliters per hour. So what I'm going to do is I'm going to set it up that way. So like my methodology for this is I'm going units per hour and I'm converting it to milliliters per hour. And I'm using my IV solution or my IV bag in order to make those conversions. So this is even what you're doing in the heparin protocol, right? You calculate, you take your patient's weight in kilograms times the 18 units per kilogram per hour, and then you get units per hour, and then you convert it to milliliters per hour. So it's the same thing I'm going to do here. I'm going to take my 750 units per hour. I'm going to look at my IV solution to see if I can eliminate units and convert it to milliliters. And I know that I can because that's why this question is here. I have 25,000 units of heparin. And then it says 1 liter bag. So you need to make sure you might mark that as 1,000 milliliters. So make sure you convert liters to milliliters before you kind of proceed with this question. Then we're going to take the numbers we got, 750 times 1,000 divided by 25,000. And then so the first scenario, you'll get 30 milliliters per hour. I'm going to do the same thing for this. It's basically the same question. It's just that they changed the units per hour and then the milliliters in the infusion or in the IV bag. So I'm going to take, for me, I always start off with this. You can, if you prefer to do this a different way, that's perfectly fine. I just always go from one rate to the other rate. It's kind of like, have you ever seen in your car, you can go miles per hour, or you can even switch it to kilometers per hour. So if you were like driving into Canada, you might need to switch to kilometers per hour, and you're just making that conversion. So that's how I'm kind of wrapping my head around this when I think about doing these things. So I'm going to take the 1250 units per hour. And then again, I want to get rid of units and convert it to milliliters. I have 25,000 units in this particular example, and then 500 milliliters. I'm going to take that 1250 times 500 and then divide by 25,000. And then I get, in this answer, I get 25 milliliters per hour. And then finally for 27, instead of heparin now, it's insulin. Insulin just happens to be in smaller units as far as units are concerned, but I'm going to handle it the same way. 15 units per hour. I don't want units per hour. I want milliliters per hour. So I'm going to use my available units, which is 100. And my IV is 500. 500 times 15 divided by 100. And you're going to get 75 milliliters per hour. So these are good ones to practice too, because it's just a matter of practicing that conversion of milliliters per hour or units per hour to milliliters per hour. If you were going in the reverse direction, you would just flip what you are using, like as far as units per milliliter are concerned. So like, let's say I was going from milliliters per hour to units per hour, which sometimes ATI asks questions like that. I don't think you're going to see something like that on your actual test. But if it's there, all you're going to do is, instead of doing 500 milliliters over 100 units, you flip those around. You do the 100 units on top, the 500 milliliters on the bottom, and then you'll get units per hour in that scenario. And the reason I'm telling you that is if you ever get stuck, that's the value of understanding how to manipulate the numbers when you're using dimensional analysis. Keep the things together that need to stay together, and then you just flip them, because that's the math that you're allowed to do with that. You can kind of determine where they go depending on what you're trying to convert to. All right, any other questions? Okay, 18. Give me 1 second. All right. Okay, so you might see some of these questions. Well, obviously that's whoever put this together obviously included that. So basically you want to be able to convert your flow rate from when going from flow rate to cc's per hour to just hours or just the time. Most people have no problem with the how much time, but then sometimes if there's decimals, it's like, well, how do I calculate minutes? So let's see what this ends up being. So my strategy whenever I do these is I will start off with the 420 cc's, and then I'm going to convert the cc's into hours by getting rid of cc's. Okay, so 1 hour, 120 cc's. So if you're doing ordered over available or desired over have for these types of questions, they can work. You just have to make sure you're organizing it in the proper uh, proportions. So 420 divided by 120, and I'm going to get 3.5, which is just 3 hours, 30 minutes. If for some reason you got an answer, like let's say you got an answer of 2 point it's like just keeps repeating kind of number, what you would do is you would say, okay, well, I'm going to take this part, the 0.6 repeating, and I'm just going to multiply that by 60 minutes. And then my answer will be 2 hours, and then whatever 60 times 0.6 repeating. So if I take 60 times 0.66666, you're going to get 39.99999. So it'd be 2 hours and 40 minutes. So if you ever get to that part where you're like, what do I do with all these decimals? If they ask you this, I don't think that they will. That's how you would convert a decimal into minutes. You just multiply by 60. You can multiply the whole thing by 60, but then you're going to get something like if I take the 2.6666 times 60, you're going to get 159.96, which is 160 minutes. And then you have to go back and account for the hours. So if you just multiply by the decimal portion, that'll give you the time that you're looking for. Go ahead, Lauren.
I'm sorry, I'm confused. Where did the 2.66 come from again?
I just gave it as a scenario. So if you got a answer when you're doing the calculation and it told you and you got an answer that was like after you did your calculation and it came out to like 2.6666666, if it's asking you to calculate hours and minutes, then I just showed you how to convert that 0.6666666 to minutes. So it's not, yeah, that's all. So it was just a scenario. It wasn't the answer to this particular question. It was just a different example. Sorry if I made that different. So and then Dawn, you're asking a good question. That's a great question to ask your instructor. if it asks for hours and minutes, I would write down the hours and minutes. But they might be okay with you writing 3.5 hours. I don't know the answer to that. And then Lauren, just so you have peace of mind, I don't think that you're going to get something that's like 2.6 repeating and then be asked to convert hours to minutes in that scenario. But if I don't at least tell you, then I feel like I haven't done a good job for you. So
Yeah, in the answer sheet, it says 3.5 hours.
okay, so that's what it says in the answer key.
Is that the answer key is provided by you or the teacher?
I did not put this particular thing together. Some of these questions are mine, but someone else put this together.
Okay, it must be the teacher's then. Yeah, it says 3.5 hours. It doesn't say like, 3 hours, half and 30 minutes, whatever.
Okay. Yeah, but I would say just to be on the safe side, because like I said, I don't know who made this, and if everyone has a different lab instructor, the lab instructors are the ones grading it, and they might tell you, oh, this is what we were looking for. If it's me grading it, I would look at 3 hours, 30 minutes and 3.5 hours as the same thing. And then I would give you that answer. I would say that's correct, unless I specifically told you otherwise. So that's why I always say ask those questions. That way you're not like counted off for like a silly mistake, because they wanted it to you to write hours and minutes as opposed to just writing 3.5 hours. My guess is that 3.5 hours is perfectly fine.
Maybe it's a good thing we need to put in the bracket.
Yep, potentially.
My answer key says 3.5 hours and then it says 210 minutes.
Okay. Yeah, I don't know why it says that, but you're saying that's what it says in the key?
Yes, it says 3.5 hours and then it says 210 minutes.
Okay.
Yeah, they just say multiply like
Okay.
3.5 by 60.
Yeah, I don't know why they have it listed as that, but yeah, 210 minutes is the same thing as 3.5 hours. So okay. All right. So we have about 10 more minutes left. Are there any other questions? Sure. All right. So marking the syringe. All right. So when you're marking the syringe, step one is make sure you choose the correct syringe to mark. It's always going to be this because it's the only one that has units listed. I always tell students that you always want to just at least write in the information here so that there's no question that you know what you're doing. So the solution, the amount to be drawn up first, 22 units regular first. And then the total is just adding the two numbers up. So 58 units total. Just make sure you indicate that you know, and that they know that you know what you're trying to mark on here. Now, part of this is they're trying to make sure that you know to put an arrow on the numbers correctly. So like these are increments of 2, right? So 52, 54, 56, 58 right here. So this is the total mark. Now, when you're doing this the correct way, I'm going to show you the way that the textbook shows you how to do it, or a textbook shows you how to do it. Remember, you drew regular insulin up first, okay? If we were in a vacuum environment and everything was like and the liquids did not mix with one another, the part you would draw up first would be closest to the plunger part of your syringe, and the part you draw up second would be closer to the needle part of the syringe. So what I'm about to show you is why it is written in the way that I'm about to show you. So you're going to make a mark at 58 and you're going to make another mark at 36. Now, the distance between 36 and 58 is 22. And this is your regular insulin. There's 22 units here. And then from this point to the 36, that's your NPH. And again, there's 36 units here. This is how they want you to mark the syringe, indicating that your regular insulin is in that range right up to the 58 units. Now, I have seen where at least on the 110 test, the way that they ask this is they just ask you to mark the total number. So choose the correct syringe, mark the total. And then for the paper tests, they might still be using this question, but this is what they're asking you to do when you're marking it. All right, 29. Yeah, so now we have to figure out, okay, well, where are the milliliters? So those M's are not milliliters, okay? So your milliliters are down here. So if it's asking you to mark on the syringe a milliliter, and it tells you it's a 1 milliliter tuberculin syringe, and here's the 1, you're going to make a mark right here. Whoa. So that's your mark. Okay, so sometimes they'll ask you to make a mark, maybe indicate it with an arrow. Okay, but they want to make sure you're marking at the correct part. So if you're sitting there trying to figure out where's the 5, between 4 and 8, these are not milliliters. I'm not even sure what this number is. It might be a completely different unit of measure. Good questions. Did everyone get this packet? And are there any changes to what I'm showing you?
Yeah, we had the same one.
Okay, good. Yeah, so the secret to this, guys, is just because, you're almost done. I know that you're tired of doing these tests, but the secret is just to practice these, practice. And if there's extra, you need extra help with anything, then just say, hey, can you work through this question, that question? And if you can't come on any of the other times that I'm meeting with students, just email me and let me know, and I'll work it out during one of the review sessions, and then I'll post it up you'll see it up on YouTube during that session. So you might just have to go and check or ask me if I did it for follow-up. But all right, so I'll be back at 6:15, I think. Yeah, 6:15 for the next part of the dosage calc, if I can pull up my thing here. Yeah, 6:15. So if you have other questions between now and then, just reach out to me, and I'll go ahead and end it there. And like I said, if you have any other questions, just email me. I'll have this uploaded either this evening or tomorrow, and it'll be on my YouTube channel, and you can see it there.
Thank you.
You're welcome.
Thank you.
Thank you.
You're welcome.
Thank you.